Are you recording? Where are you?
Who keeps blurting? Is that you, Grayson?
Huh?
I tell you that keeps blurting? Fundamental rule, 5th grade, when I'm standing up here talking, guess what you're doing?
Ready?
And you can't listen and talk at the same time. Well, maybe you could, but you shouldn't. So just remember that. I stand up here. Silence is always a good deal unless I ask for something here. Subtraction, ladies and gentlemen. Write that on your piece of paper. Subtraction. And today we get to use that favorite word of mine, which you have already written down. The book calls us practicing the subtraction algorithm, which, if you remember, the algorithm is was the process that you do. Now, I've seen 5th graders, and while most of them know how to do subtraction, sometimes they get a little confused in the subtraction algorithm. Let's just look at a couple here. Just a couple example problems and see if everybody's on the same page here. And these are a little bit bigger subtraction problems. If you have 219 minus 73. If I asked you the process or the algorithm of doing that, the first step, Eliza, is to do what? What will be the first thing you do? If you see this problem in your book, you're going to go, okay, first thing I'm going to do,
Write it up.
right, you're going to write it like a normal subtraction problem, because this is just how we do it, right? And when you write it up and down, you line up, we call it right justifying it. We line up the right side so that they fall under each other there, right? And this is stuff you've done before, so it's not like, it's not anything that you haven't experienced before. Here is where we have to look here. We start in the ones column, the units, and we do subtraction from right back to left. You take 9 and subtract 3, that's a 6, right?
Yeah.
Okay, but here is where we need to make sure we're all on the same page as far as what happens here. I cannot take 7 away from 1, so we have to do everybody's favorite thing in the world, which is borrowing. And I know people do this differently, but I'd like to see it like this. Okay, you have to borrow from the 2, so it gets crossed off and you put a 1 up there. What happens to this 1?
Goes to 11.
Yeah, you make it 11, and I very much like to see an 11 up there. I know sometimes maybe put a hash mark there or whatever, but I like to see that, especially when we talk about the next problem here. Then you can subtract 7 from 11, which is 4. There's nothing here, so you say 0 from 1, you get 1, and your answer is 146. Okay. Now that's a relatively easy problem. Hopefully most of you say. Where I see a lot of mistakes are when people start subtracting these sort of numbers. 600 minus 271. Okay. It's like when you have to borrow from farther away than just one place. Since I can't take the 1 away from 0, I have to try to borrow from this 0, but I can't borrow from that 0 because there's nothing there already, so I have to go all the way to the 6 and borrow from that, right? It becomes a 5. Then what happens? Grayson?
You'll go to the next 0 and then make it 10.
Right, and I'd like to see that. Some of you maybe skip a couple steps there. You make this a 10.
And then you have to cross it out.
Right.
Put it at 9 and then
Right, then you have to cross it out because you're borrowing from that 10, it becomes a 9, and then this becomes a 10, and so on and so on. And then I see people get so used to crossing off these things that they start crossing this off and making it a 9. No, you're all the way at the end, you don't cross that off. That's 1 from 10 is 9, 7 from 9 is 2, and 2 from 5 is 3. Which, while we're on that whole subject here, how many of you think you're relatively good at math? I like that. You should be able to, if you're relatively good at math, and not everybody can, you should be able to do this problem for me without, this would be one where I would say you should be able to do mentally for me. Nah, wait, I don't like that.
1 million?
1 million, minus 736,425. If you're good at math, If you're good at math, right off the bat, you should be able to tell me the answer to that is 263,575.
Totally. Good job.
And it's not that hard if you think about it. Okay? Why is it not that hard? David?
Because you just say like you add up to 9 the number you're subtracting.
If you think about what we just did there, if I actually, I'm going to do it out long and you'll see why that works out nicely here. If you line up the things here and you put 7, 3, 6, 4, 2, 5 there, if you are borrowing all that stuff like we just did in the last problem, remember this becomes a 0. This is going to be a 10, but we have to cross it off and make it a 9, right? Which makes this a 10, but we have to cross it off and make it a 9. But this makes this a 10, but we have to cross it off and make it a 9. But this makes this a 10, but we have to cross it off and make it a 9. Which makes this a 10, but you have to cross it off and make it a 9. But this one has to stay a 10, right? Yeah. So when you cross it all off, you end up with 9, 9, 9, 9, 9, 10. All you have to do is think about this. What added to these numbers will give you all these 9s on top, and then this one has to add up to a 10. 2, 6, 3, 5, 7, 5. So they just have to add up. See, this to get to 9, you have to add a 2, a 6, a 3, a 5, a 7. But the last one has to be a 10, so it's a 5. Let's see if anybody picked up on that. If you don't get it, it doesn't matter, but that's okay. 1,000 minus 804. What added to this would give you a 9? 1. What added to this would give you a 9? 9. What added to this gives you a 10?
6.
196 is what you'll get when you subtract this, because those have to add up to 9s and that has to add up to a 10. I mean, you could do the world's largest number. You could do a billion.
Oh, yeah.
Wait,
No,
is this-
quadrillion.
Is that a billion? Yeah.
There's a trillion. There's
a
trillion.
Wait, million, billion.
There's quadrillion.
7, 2, 3, 8, 1, 9, 0, 0, 2. And you could tell me the answer to that, because all these are going to add up to 9s, except that's going to add up to a 10. You would say this is 276,180,000, that already is a 9, 1,998. That one has to add up to a 10. That's just it. But that only works when you have a bunch of zeros. Anyway, back to reality. Maybe that helped you, maybe that didn't. How about do this one problem for me here. Let's see if everybody gets the same answer. 800 minus 406. I'll give you a second to do that on your own. Let's see how many people get that answer, and if you get it, we're just going to cruise on the homework there. This one is not really mental, although you could do it mentally if you could. Kind of. Jackson, what'd you come up with?
394.
394. Let's check and see. You can't take 6 from that, so you got to borrow from that, which means you got to borrow from that. This should have been a 7, which made this a 10, which makes it a 9, so you have to borrow from that, which makes this a 10. Please don't borrow from that because you don't have to. 6 from 10 is 4, 0 from 9 is 9, 4 from 7 is 300. And they get the big old